further delay. So let me share my screen and we'll start with this discussion on multi-level modeling. Um, and yes, I am reminded of Skills Edge, and Dr. Manish is also here. Manish, if you want to introduce.
This is a very good afternoon to each and everyone. I am Dr. Manish Panchasra, and presently I am a co-founder of SkillsAge, carrying the idea of Vishal sir.
And yes,
That
and doing everything that you see behind skill sets. So thank you, Manish, and thank you everybody for joining. And so we have a varied group in terms of nationalities. We have people from Belgium, from Nepal, from India. In terms of experience level, we have some advanced stage PhD students. We have people who have just joined the PhD program, people who are starting, people who have completed PhD and are working as faculty. We also have people working in varied areas, as you would have heard. This is why the introduction is important, just to give us a flavor of the participants. So, what I plan to do in this workshop is I want to introduce you all to the basics of multi-level modeling. Okay, what is multi-level modeling? Why should we do it? Yeah, and what is the idea behind doing this kind of modeling? What are the different kinds of models that are available? And then we'll look at two examples, one from organization behavior, and we will look at one example from education. So we'll do that using both R and SPSS, and then similarly, when we come to longitudinal analysis, we'll look at two examples, one from OB area, another from again education area, given that these are two areas in which I work, and so I have brought examples from. But you would find multi-level modeling being used in various disciplines, okay, in various domains. Also, what I plan to cover in this workshop is regression-based multi-level modeling. Multi-level modeling today can also be done using covariance-based structural equation modeling. But in order to do multi-level models using SEM, you need to know both regression-based multi-level modeling as well as covariance-based structural equation modeling. So that is not something that I'm going to do, because first of all, to understand SEM-based multi-level models, we have to understand what is multi-level modeling. So in this workshop, you can say that this will lay the foundation of multi-level modeling. People who are looking at their research ideas, you can better appreciate what is going on, and you can actually think of doing this analysis using regressions. And once you have an understanding of this, you can, and you have learned covariance based structural equation modeling, you can then combine this and create the third level or a higher level of understanding, which is multi-level structural equation modeling. So we call it as MSEM today, multi-level structural equation modeling. But in this workshop, we'll understand regression-based multi-level modeling. So the agenda is, I want to part one, which is largely the first 3 or 4 days, that is this week, and then maybe on Monday, I want to present to you the big picture overview of multi-level models, and we will practice the examples using R and SPSS. And in part two, we will use the understanding of multi-level models to go to longitudinal modeling. So longitudinal modeling is also called as growth modeling, okay? And I will introduce you to this, and then we will practice the examples using both R and SPSS. That's what broadly the agenda of this workshop is going to be. Okay. As I said, I will be uploading the entire recording of the session. So just spend time understanding what's going on. A lot of these terms may actually be new to you. So just think about these carefully as we discuss. So what is multi-level modeling? It is nothing but it's a statistical model that allows specifying and estimating relationships between variables that have been observed at different levels of a hierarchical data structure. Very important. You see, there is nothing different in the first three lines. A statistical model that allows specifying and estimating relationships between variables. This is what we were doing in regressions also. This is what we were doing in structural equation modeling also. But what is important in multi-level models is that these variables have been observed at different levels of a hierarchical data structure at different levels. Now let me, okay, and as I have already said in this course, we will cover examples from multi-level regression modeling. Yes, Pratik, I see you have raised hand.
Yeah, so sir, you earlier talked about the difference between MLM and MSEM. So my question was like, from the point of view of publication, do the MLM studies get published? Uh,
Absolutely, absolutely. They do get published. Not a problem at all. Yeah,
okay, okay, sir.
yeah, yeah. Okay, so let me talk about what is a multi-level data structure. Okay. Now, if you look at this example that I have shown, this was also the example that I had put in the flyer. You see, this is a multi-level data structure. Now, psychological capital impacts employee creativity. That's a relationship that we want to test, okay? And psychological capital is an individual level variable. It is my psychological capital, and I want to understand how does it impact my creativity. So, employee creativity and employee psychological capital. But then I also want to understand the impact of leadership on employee creativity, impact of leadership on psychological capital. So, what is the impact leader of a team has on employees' psychological capital and employee creativity? Now, if you see this diagram, if you see this model, leadership is not an individual level variable. Why? Because while within a team, you may have multiple employees. So a team may have, say, 5 employees, but all 5 employees have only one leader. It is not that 5 different employees have 5 different leaders. There is one team leader. So at the team level, you have one leader and you have 5 different psychological capital and 5 different employee creativity. So the leadership is not a individual level variable. We say leadership is actually a team level variable. And these employees, these 5 different employees are said to be nested. Okay, please mark this word. They are said to be nested under one common leader. Similarly, if I want to understand justice climate, I heard somebody was working on high performance work system. If you want to understand the impact of high performance work practices or justice climate, you see, there is one justice climate per team. You may have different perceptions of justice. So perceptions of justice may actually be an individual level variable, but justice climate is only one. So there is one justice climate at the team level, and I want to understand whether justice climate impacts employee creativity. And I also want to understand if justice climate impacts team innovation. So if you see this relationship, leadership, team level leadership to team level justice to team level innovation, this is all at level 2, which is team level. And I can say psychological capital and employee creativity is at actually a lower level, which is at the employee level, and this is called as L1 or individual level, and L2 is the team level. If I were to do analysis, and my question is, let's say very simply, do leaders impact employee creativity? Forget about justice, forget about team innovation. I just want to ask the question whether leaders impact employee creativity. So what am I going to do if I don't know multi-level modeling or I don't model the nested nature of the data? What I will do is I will say leadership impacts employee creativity without accounting for one leader who is common for all the 5 employees. Rather, I will say, well, I will simply regress employee creativity on leadership, ignoring the multi-level data structure, and that actually has a problem which I will come to later. This can confound your relationships or the results that you are getting in the analysis, right? So in multi-level data or in kind of the research that we do, management research, data is usually hierarchical. That is what I have written. Students are nested within teachers. You see, in a class, in this workshop, for example, we have 30 students, but there is only one teacher. We have 30 participants for the workshop, but there is only one instructor. So students are nested within teachers or schools, employees are nested within leaders, and leaders are nested within organizations. Similarly, teachers are nested within schools. So you can say it is not just two level. You have employees are nested. Let us go back to this diagram. You have individual level employees who are nested under teams, and teams are nested under organizations. Organizations may be nested under cities or industries. So you can see that there is a hierarchical level, hierarchical data structure. And theoretically, well, I can say there are infinite levels I can go up to. But usually in research, most common most common I would say is people don't model multi-level data. The next most common is people do two-level data modeling. That is, you would see a lot of diagrams which are like this. So there is level 1 and then there is level 2, and this dotted line in between actually shows that there is a difference in level. That is how we draw these multi-level diagrams, right? And then you can maximum, uh, again, advanced could be 3 level. So teams nested within organization, that is the third level that we can also model. Individuals nested in diets nested in teams nested in business units. You see, I said there could be many levels. Organizations nested in industries, and industries nested in countries, and so on. We can keep going on and say that the data is actually hierarchical. And then sampling is conducted using multi-stage cluster sampling. So you say, I want to sample these many teams. And then within teams, I will sample people. So you just don't do one level sampling. You just don't do sampling at an individual level. You also do sampling at team level. You want to kind of get data from different kinds of leaders, you want to get data from different kinds of teams, and so on. So that is what we call as, and the problem is that the higher level or this confounding that comes from level 2, level 3 are common, but they are not modeled or even considered in management research. So a lot of researchers actually fail to account that their data is actually hierarchical in nature, and the variables that they are actually using in simple regressions are not all at the same level. They are actually at different levels of analysis. Let me give you an example, and this is actually an example that we are going to study. This is coming from education area, and this is from this book Heck et al 2014 that I talked about as a reference text in the instruction sheet. I have given this book to you. The question is very simple. The question is, does student math achievement vary across schools? So what is the individual level variable here? It is students' math score. Does it vary across schools? So what is the grouping variable or nesting variable? It is schools. So students are nested within schools. That is the grouping. We are not taking here teachers or classrooms. Rather, we are saying student math achievement as a function of schools. Okay. And then we want to say whether the effect of individual socioeconomic status tend to compound at the school level to influence student math achievement. That is, do both individual level socioeconomic status and school level or aggregate socioeconomic status influence math achievement? And whether features of school context, student composition and type of school, okay, and their academic environments, proportion of students planning to attend four-year universities after they graduate from high school affect the relationship between individual student SES and math achievement. Now let me share my whiteboard and show you what we are actually talking about here. Now let's draw the diagram, and I want all of you to look at this carefully, and we should get into the habit of drawing these diagrams, okay, so that we understand, we can write these English statements in terms of a model, right? Mathematical, or first of all diagram, and then I will come to how do we write the mathematical equations for these diagrams. So what is the dependent variable? So we said that the dependent variable is students' math score. Let's say it varies for every individual. So I is the ith individual or student. Let's say ith student. And we say also J, because this student belongs to jth school. Jth school, right? What is the IV? IV, we said that let's say there is math score of a student. Okay, let me just talk about math score of ith student who is studying in jth school. This is the notation that we will be using. Now I want to see whether the socio-economic status, that means if the student comes from a wealthy family, whether the student is coming from a good background, socioeconomic status is essentially giving us an indication of what is the background of this student. So we say socioeconomic status of ith student studying in jth school, and we want to test this relationship. Let us say, okay, this is what we want to study, that students socioeconomic status has a direct impact on how well they do in mathematics exam. Okay, but then I also have another. In a school, for example, let's say we say school number 1, there are 10 students. 1 2 3 6 7 8 9 10. So I have socioeconomic status 1 1, socioeconomic status 2 1, socioeconomic status 3 1, going up till socioeconomic status 10 1. 10 student studying in first school. Similarly, let's say there is school number 2, okay, and we say again there are 10, so we say socioeconomic status 1 2, going up till socioeconomic status 10 2. Now I can also say that what is a school level socioeconomic status. So I take the average socioeconomic status of the school and I call this is a school level variable, a school level indicator. So what have I done? I have taken the average of the 10 socioeconomic status, and this is now a variable that is classifying the school. Similarly, I take the average socioeconomic status and it becomes AVG SES2. The first one becomes AVG average socioeconomic status 1. So now there is a school level variable which is average socioeconomic status J, and this can also impact mathematics performance. That is, what does this mean? A school that is higher on average socioeconomic status, that means this is a school where wealthy children are studying. That is, when the average is higher, it is giving us an indication of the school, that this school caters to wealthy wealthy kids. Okay, a school which is lower in average socioeconomic status, we can say this is a school that is catering to poorer population or poorer kids. So this average socioeconomic status can also have an impact. Similarly, we say how many students, what is the proportion of students who want to go to a 4-year college after completing their school education. This is also a school level variable. Okay, just I'm saying only, let's take only two these variables. So what is it that we get? We get that there is a multi-level data structure here. This is L1. This is individual level. Your socioeconomic status as well as the math score is for ith student nested under jth school. And then there is also an impact of school variable. And the school can also impact whether the maths performance of the which kind of school you are studying, that can also have an impact on the performance of the students. If we don't take this into account, okay, now if I did not take this multi-level nature into account, I would have simply written math. If I just write the level 1, I say math I is equal to some intercept plus I say beta 1 SES I. Okay, I do not bother about the level 2 influences, L2 influences. So I say, well, maths performance is going to be impacted by the socioeconomic status. I ignore the level 2 variable. So if I ignore, I am obviously missing out on what could have been the possible impact of the L2 variable. A lot of times what we also see in research is people model these as variables at L1, AVG, SES, and you write AVG, SES, I instead of J. That means for every individual you have the same average socioeconomic status. Again, it is wrong because you are then not. So I can also write B2, AVG, socioeconomic status I. Now, this is theoretically wrong because there is no variation. There is no variation of AVG SES for students studying in the same school. In the same school, you have every student has actually the same average socioeconomic status indicator. And this we can say what will happen that the standard error when you have people who are having the same socioeconomic status, having this average socioeconomic status, students studying in the same school, we say there is going to be clustering effects. Clustering. The normal regression says, I have it in my presentation, I will come to that. The normal regression, what does the regression say? Yes, so Swati, why I see there is, I am saying yes, theoretically you should have written J, but you are saying it is not J, it is actually I. You are assuming this is a variable associated with each individual. So the model here is, I am saying math I, forget J now. If I would have modeled it as just one level data, I would have said SESI and I would have said SES. I am not actually modeling that there is any J at all. There is any J level influence at all. Okay. I am saying that I am taking all of this as one level data only. Then there is only I. There is no IJ. That is what I'm saying here. Okay. So let me erase this and say if I were modeling only as L1, only one level. Now you can see this is what we do in our research, that we say leadership, rather than saying it is a J level variable, we say leadership is a I level variable. And then I regress my performance with leadership. I regress my student achievement with with uh, 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 average SES, right? Now SES is actually, it should have been, or it is same for all students studying in the school. So it should be J, it should not be I, but you have modeled it as I, that it is varying for every individual, but it is not varying actually. So that's a wrong understanding of it's a very wrong understanding of how we model our data. And then because there is clustering in regression, we theoretically say one of the assumptions of regressions is that all observations are independent to each other, right? All observations of math ij, all observations of ses ij, okay, are independent to each other. Essentially that means there should be no correlation. But now you can understand, because these are students not just impacted by SES, they are also impacted by average socioeconomic status, a school level variable. So there is going to be correlation, right? There is going to be clustering because of the nesting nature, or you can say hierarchical nature of data. If there is hierarchical, if there is clustering, then what will happen is that very simply you can understand that your standard errors of regression coefficients of beta 1, of beta 2 are going to go down. Because what is standard error? It is nothing but deviation. It is capturing the variance of your observations. So if there is clustering, clustering has an impact on standard errors going down. So you will have actually standard error beta 1 going down, standard error of beta 2 going down because of the clustering nature. And if you don't model that, and remember, what is our T stat? Our T stat was beta 1 divided by standard error of beta 1. This is what we used to write in regression hypothesis testing. And the second T stat is beta 2 divided by standard error of beta 2. Now if your standard errors are going down, the variance is small because of the clustering nature, what will happen to the overall T stat? What will happen to the overall ratio? The overall ratio is going to go up. So you are actually, we say that your T stat, okay, and then I will stop and take some question. The stat, when we fail to model hierarchical nature of data and have clustering, the T stats are inflated. Okay, this is a fundamental understanding that you must keep in mind, that our T stats are inflated when we fail to model the hierarchical nature, because all these observations are going to be correlated according to schools or according to leaders, and their standard errors are not independent, and so there is going to be clustering. And when the standard errors go down, the overall T stats become higher. So rather than you were thinking that you are testing the hypothesis at 5%, but no, you may actually be testing, the actual testing is not at 5% but maybe 15% because of inflation. So your H naught that you are rejecting is not a 5% test, it is actually a 15% alpha that you are testing, and you are saying that yes, my regressions, my relationships are significant. And that is a fundamental problem when we talk about this one level. Okay, let me write it here. One level modeling of data. Rather, what we need to model, or what we therefore should do, is that we model it this way, and this is called as multi-level modeling of data. Now let me take a pause and see if there are any questions. So I see Swati, Jaya, and Pratik. Yes, Pratik, go ahead.
So sir, in this, like my question was from very early on. So
Hmm,
this diagram you made actually. So in the level one, it goes from SES IJ to Math IJ, which is
correct.
pretty understandable. But uh, in some cases, in some multi-level papers, I have seen that they will aggregate the Math IJ to Math J
Yes,
and relate to average SESJ to Maths J, and no,
yes,
but not to the L2 to L1.
yes. So you see, good question that you ask, and I have it in my slide later on. If you, so what Pratik is saying, I can have a model something like this also. So I say AVG SES J is related to AVG Math J, correct? And he is saying that I also have SES IJ to Math IJ. And I know that this is at 2 level, this is at level L1, this is at level L2. Right, this is what you are saying, Pratik, that
Yes, sir.
I simply have a relationship between average math J to average SES J, and I have individual level. Now you see, this is actually, I would say that this is not the multi-level modeling that we are trying to learn, because you see this relationship, is it multi-level?
No.
This is only one level,
Yes, yes.
even though it is at level 2, but it is only one level relationship. Is this relationship multi-level?
No, no.
No, right? This is also one level only, and this is at level 1. I would like to believe, therefore, Pratik, that when we say multi-level, we are saying that there is a relationship which is having variables at multi-level. I am trying to understand the performance of Math IJ by explained by variables that are at multi-levels. One variable SESIJ is level 1, other variables are level 2. Or we can say, therefore, you would see in some books or some papers, we can say these are also cross-level relationships. That there are cross-level. These example are examples. Yes, you have data at two levels, level 1 and level 2, but the relationships are not testing multi-level uh, relationships. Is that okay, Pratik?
Yes, sir. In some papers, I have actually found out that so there will be individual creativity, and then there will be team creativity,
Creativity.
and yeah, so they sometimes they will draw at level two, for example, leadership team creativity, but they will not
Have
cross
arrows,
level.
have arrows crossing, right?
Yes, sir. Yes.
Yes, yes, yes. It is possible. It is possible. It is up to you. But you see, for doing this relationship also, Pratik, you don't need to learn multi-level models. You just aggregate and then you do simple one-level regression that you already know. Correct?
Yes, sir. Got it.
So
Got
you
it.
don't need to do multi-level modeling at all. You can simply aggregate and then do the normal regression that we know. Okay,
Got it.
there is no need to do any advanced level of analysis. It still continues to be a normal regression. That's it. Normal regression or SEM, whatever you want to do, you can do it. The challenge is when you want to bring in levels, two levels or multiple levels, that is when we need to understand the mathematical formulation.
Got it, sir. Understood.
Yeah. Yes. Tanika?
So my question has partly been answered, but I'm here thinking aloud and maybe asking a very stupid question, but I'll still ask.
Yes.
The question is, sir, is it also similar to something like a corresponding analysis or something like that that we do that within, for example, I have work engagement scores,
Yeah.
and my modeling is done at an individual level only, and I'm studying my research objective and question is to analyze at the individual level.
Okay.
But I'm also curious because I've collected data from 15 different companies. I
Yes.
would also want to know at a company level whether there is a difference in the means of the work engagement for these 15, and if there's something interesting insight that is coming out. Do you think that we can, is that also a question which can be
So
answered through this kind of analysis?
it can be, but let me tell you,
Okay,
when we say multi-level models, we say that you should have, in general, about 30 different level twos also. See,
I see.
level ones you may have 100, but those
Sure.
level ones are only in 15. Okay.
Right,
So
right.
but yes, you can definitely do. Now you can, one very simple analysis, even with 15 companies, you can say how much of this work engagement is explained by level 1 and how much of it is explained by level 2. That means,
See.
if I
Okay.
were to say that out of the total variance that I know of work
Mm-hmm.
engagement, say
Mm-hmm.
20% is because of organization, and the remaining 80% is coming from individual level, whatever antecedents I have measured, right? This,
Right,
but then what do you, so yes, I now know 20%, but then
right.
is there an explanatory variable, like here we had AVG, SES, or Pro 4 year, or leadership, whatever? Is there a organization level variable that you have measured that you want to test whether that can explain this 20% or not?
Got it, sir.
That you
Okay.
should have, again, that is where, remember, the fundamental thing, that all of this need to be thought of at the design stage. If
Sure,
now,
sir.
after
Right.
having collected the data, I
Mm.
don't have any organization level variable,
Mm.
I can only say this much, that there is 20% contribution because of organization. But then what about organization?
Got it, sir. Okay.
For that, you should have measured, say, high performance work practices, or culture, or leadership, or whatever, which is, you can say,
Mm.
is a L2 variable that varies between organizations. Is that making sense?
Understood. Yes, yes, sir.
Yes,
Totally,
but
totally. That makes sense.
this we can definitely do, and I will teach you how to do this. You can figure out how much of work engagement is
Yes.
because of L2 and how much of work engagement is because of L1. This we can figure out. We actually
Right.
have a name for this. We call this as ICC1 index, intra-class correlation index 1. I will teach you how to compute this.
Right.
This number will tell you. So you will get, if ICC1 comes out to be 0.20,
Hmm.
it means 20% is because of L2, 80% is because of L1.
Got it, sir. Got it, sir.
Okay.
Thank you.
Yes.
Yes. Thank you.
Yes, Nivedita.
Sir, so my question was, now if, for example, we want to study the leader's mindfulness,
Okay.
and we are measuring it through the team members' perceptions.
No, just,
And
okay. Tell me once again. Let me write it on the board. Yes. What are you trying to measure?
so we are trying to measure perceived leader mindfulness.
Okay. So and this is DV.
Uh, yes.
This
No,
is
this is IV. This is
this is
IV.
IV. So let
Huh.
me, you are saying perceived
Leader mindfulness.
leader mindfulness. Okay. Go ahead.
So, now we want to see how this influences, maybe say, the team mindfulness. and also the team performance.
Okay, so you are saying DV is team,
Mindfulness,
team mindfulness, and
team performance.
team performance. Okay, right?
So, I want to ask, the perceived leader mindfulness will be collecting the data from the members, team members who are
So
there
you
under the
have,
leader.
yes, so you have, let's say, one leader, and let's say you have four employees.
Right.
Okay,
Hmm.
then you have second leader, let's say you have five employees.
Hmm.
Then let's say you have 15th or 30th leader, and you have five employees.
Right.
Okay, yes, now go ahead.
So, since we want to understand the perception of leader mindfulness as seen by the team,
Hmm.
if I am to aggregate this at the team level,
Yes,
then will this be L2 level
yes,
variable?
yes. Now you have asked very, very good questions, and something that I have it on my slide that we will be talking about.
Okay.
Now what you have said, okay, and for the benefit of everybody, let us think about it, and then when I come to the presentation, I will explain this again. So when I ask the employee, what I ask the employee is, tell us about your leader's mindfulness, correct? Which you are
Yes.
saying. So you say, okay, tell us about your leader's mindfulness, and this is IJ, right?
Yes.
This is rated by employee one working under leader one. So we
Correct.
call this as LM11. Then I say, go to employee number two, and I say, tell us about leader mindfulness, and I say 2-1. Then employee 4 is 4-1, and employee 3 under leader 1, right? So now you can say, you see, in research, whenever you see this word perceived, what should this tell you? That this is a IJ variable, because perception is varying for every individual. It is an individual level variable. It is varying for every individual, right? That is my IJ variable. Team mindfulness clearly is a J variable. It is a team level variable, and team performance is clearly a J level variable. Is this okay with everybody, or anybody has doubt on this? IJ, J, and J. Is this okay? Similarly, now you have LM 12, LM 22, LM 32, LM 42, and LM 52. And similarly, you have L 130, L 230, L 330, L 430, and L 530. Is this okay? These are all IJ variables. Now what do I do? I can aggregate. So this word we will talk about, and we will see in our later discussion. This word is called as aggregation. Aggregation. So what do I do? I want to bring these IJ variable to actually a LMJ variable. Leader mindfulness J variable. So what do? I take the average of these four and call it as aggregated or average mindfulness J variable.
Uh,
And yes,
Sorry for interrupting. If I could ask you for a small help, could you please draw it like a model as we were doing it
I will.
previously?
Yes, I will. Don't worry.
Thank you.
So this will become AVG LM1, AVG LM2, and this will become AVG LM3, LM30. Now, what is the model? What should be our model if this is the research question that Nivedita asked us, right? Let us keep thinking, right? As we study this, let us keep thinking and keep drawing these models. And I always like to draw models, so I will always draw models. So I wanted to understand team mindfulness J, and I wanted to understand team performance J. These are my DVs. What is my antecedent? The antecedent now is my AVG LMJ, and I want to test whether this has an impact on team mindfulness and team performance, and this is all modeled at level 2. This is L2. What is at L1? What is at L1 that we have? We have LMIJ, leader mindfulness, or we can say this is perceived leader mindfulness IJ. Now this perceived, now you see individual level variables, we typically do not model an arrow going from L1 to L2. We always draw top down. So if there was, for example, employee creativity, which is an IJ variable, then I could have said that leader mindfulness can impact employee creativity, and also perceived leader mindfulness can impact employee creativity. So I can have both arrows coming from L2 to L1. But to say that, let me choose a different color. To say that a lower level variable can impact team performance and can impact team mindfulness, this is something that we don't model. Because to theoretically also say that one perception can impact overall team mindfulness or overall team performance, that is not something that is theoretically also very intuitive, and also mathematically the way these techniques have been developed, we don't model L1 impacting L2. So what is in our modeling, let me say, write it here on the board, that we always model L2 impacting L2 and L2 impacting L1. This is accepted. But L1 impacting L1, this is also accepted. But to say that L1 will impact L2 variable, this is something that we don't model. This is something that we don't argue or hypothesize when we are doing these kinds of models. We say that higher level variables will impact lower level variables. Is this making sense, Nivedita and others? Any
Yes, sir.
questions? Yeah, this would be your model. And then you will aggregate, and then there are some indices that I will teach you, which you need to show in order before you aggregate. Okay, so that is something, but theoretically, yes, you can aggregate and then test the relationship.
Okay, sir.
Okay,
Thank you.
yes. Yes, now Jaya, you want to ask your question, and Swati.
Sir, I have a question for sampling method.
Yes,
Suppose my study is experimental in nature and I have trials nested within individuals. So
okay.
in that case, will we call it a multi-stage or a simple random sampling or any other like snowball or any other
So what do
sampling?
you mean? Okay, let us look at Jaya's question, because these are all important clarifying questions which will help us. So when you are saying experiment, you are saying there are experiments nested under an individual. What does that mean? You are saying that there is an individual one and you have measured this individual at multiple times?
Yes, yes, the number of trials under the individual. So individual one is being tested on 15 trials or 20 trials. So
Okay,
those trials are nested within that individual, and
okay.
that way it is.
And
Mhm.
these are same trials or different trials?
So these are similar kind of trials, but the items are different. So if I am testing exploratory behavior of a student, so exploratory behavior along with those 15 trials are nested within that individual.
So theoretically, yes. Theoretically, yes. These are, you can say that you can model that these are your L1 and this is your L2. That
Mhm.
these are nested under one individual. So you can say you can partial out what is the influence of the individuals and what is the actual influence on or impact of these 15 trials on whatever out. I assume you have a DV which is also at level
Yes, at the level one, the
at
knowledge
level.
exploration, the
Yes,
willingness to explore information.
yes. So this is also your IJ.
Mhm.
Then you have your trials also at I1,
Mhm.
and you can then
Mhm.
partial out the impact of individual J.
Mhm.
Okay, and if it was if it was time instead of trials, this actually becomes a typical model of longitudinal,
Yes. Mhm.
right? Which is the same individual, but we are taking readings at multiple times. Then this is
Mhm.
a longitudinal kind of a design. But broadly, what I am hearing is you can, yes, you can model this as multi-level and see if there is some L2 impact. So you can say age, gender, etc., which varies between people, not within people, right?
Mhm.
So
Mhm. Mhm.
these are all J level variables, and you can partial out the impact of these L2 variables and then see how much is the impact of L1 variables on your outcome.
Mhm. Yeah, got it.
Yeah,
Thank you, sir.
yes. Okay, and the reason for not making what Richa is asking in the chat, not making L1 impacting L2 because theoretically this is not correct, okay, or theoretically it is not something that can be argued very strongly that one individual in a team is impacting entire team performance is something that we don't argue so often, okay, but more importantly, the way these techniques work, these algorithms work, they don't model the L1 impact on L2, they model the top down impact of L2 variables impacting L1 variables, right? That is why we do it this way. Okay, so let us come back to our presentation. This was the example. Now that we have understood, now you see, if I were to write one equation, this is what I have written here. Okay, this is what we were doing up till now. Okay, this is what we have been doing when we are doing regression analysis. We say my math performance varies as per socioeconomic status. So single level multiple regression model to explain an individual I math achievement outcome would be yi is equal to some intercept. This is your intercept beta 0, and then there is beta 1 which is slope, socioeconomic status I, and some error residual. This is diagram is taken from the book Heck et al. Now very interestingly, if we plot, okay, this is I have just plotted, or in this diagram This diagram shows that this is relationship between maths and socioeconomic status for 80 students nested under 6 schools. So you see there are 6 different regression lines. Okay, so let's say school number 1 has 10 students, school number 2 has 10 students, school number 3 has 10 students, and then the 3 remaining schools have 13, 13, 14 students. So we plot a regression line between math and socioeconomic status for every school. Now, when you look at this diagram and you compare this with the previous diagram, is there something that you see which is different? When we were modeling just one line for math and socioeconomic status, and now that we have plotted 6 different lines for 6 different schools, is there any observation that you see? I want to ask you, take a look at this diagram and tell me what are you seeing? Anyone? You can unmute yourself and tell me.
So that some school have some school the math and SES are not that related, and in some school that is very highly correlated.
Yes,
Uh,
yes, yes. So very good observation. What Pratik is telling us that in some schools, you see, in some schools you are seeing a positive line. In some schools you are seeing a steeper line, right? And very interestingly, look at this line. Here, math and socioeconomic status, as socioeconomic status is increasing, math score is actually coming down. So we say that the slopes of the lines are varying, It is not just one relationship. What until now I was saying that there is only one relationship between maths and socioeconomic status. This is actually wrong, very wrong, because now what I am seeing is that different schools exhibit a very different relationship. One school is showing a steep rise, another school is actually showing a decline. As socioeconomic status is increasing, math performance is actually reducing. And then look at this school. This school had a smaller mean, it had a smaller starting point. If socioeconomic status is here, you see math score was here, but this school had on an average very high mean, above 60. But then as socioeconomic status started to increase, the math score started to fall down. So there is now, friends, I am writing two terminologies that are going to be very, very, you will say we will be using this repeatedly in the workshop. We say there is a random intercept and random slope. That means the intercept is varying now for schools and it is varying randomly. That means there must be something. There is a variation in the intercept. There must be something happening at the school level, that some schools have a very small mean, some schools have a high mean. And then there are random slopes also. That means there should be something at the school level, that some schools show a steep rise in math score, whereas some schools are actually showing a decline in math performance as socioeconomic status increases. If I don't model this hierarchical nature, I don't model this, and I say, well, there is one line, this is the intercept, and I am only saying this is overall. But then what is happening at the hierarchical level, at the L2 level? What is it that is at the school that is actually causing this change? If I don't understand that, how will I make a policy? You will simply say that, well, increase socioeconomic status and math performance will increase, but it will not increase for this school. I need to therefore account for something at L2 which otherwise can make me go wrong in my analysis, in my interpretations. That is the idea of multi-level models. I need to talk about what's the variation at school level, at L2 level, and then what could be those predictors at L2 level that can help me explain that apart from just the individual level socioeconomic status, there is something at school level that is also impacting this relationship. And if I don't decipher that, if I don't understand that, then I am doing injustice to my data. I am doing injustice to the analysis, and I am making wrong interpretations and wrong suggestions for my research. This is another example that I have taken from the Blees PDF that we will do this example as well. Now you see, this is a relationship between well-being of a cadet and the leadership, perceived leadership or leadership of the platoon. And this is plotted for 25 platoons or 20. The data that we will work on is taken from military setting. So there are 25 platoons, and you have observations, people nested under different platoons. Now if you see, this is a plot. We will make this plot as well in R. If you see this plot, what are we seeing? Again, you can see that there is a difference in slope and there is a difference in intercept. Some platoons, compare platoon number 21 with platoon number 25. Compare these two platoons. You see the intercepts are different or about same, but you see the slopes are quite different. If you compare platoon number 25, let's compare platoon number 25 with platoon number 2. You see the line is less steep. Here for platoon number 25, the line is steep. Look at the intercept is small. Look at this intercept is high. That means this platoon number 2, has on an average a higher well-being. The mean is higher of well-being. Here the mean is smaller, but as leadership improves, they show a steeper rise in well-being, whereas here the rise is not. So what is happening at the L2 level? What is the explanation? Is there something at platoon level that is impacting? Is there an influence of other cadets or some group level feature that can help us understand this relationship better? If we don't do this kind of an analysis, we are missing out on the richness that we could otherwise have understood. And this is, again, you can say, we will use the terminology that this model is showing that there is random intercept and random slope. That means the slopes are different for different platoons and the intercepts are also different for different platoons. I have just plotted 25. In the data there are 99 platoons. Okay, but it is showing us that there is a variation per platoon in terms of the relationship between well-being and leadership consideration. So to what is it that what is it that multi-level models allow us to do? They allow us to calculate standard errors more accurately. Okay, I talked about it. Offer insight into how effects vary at higher level within the structure, and then permits the inclusion of predictors at different levels within the model. So you just don't get insight, you can also explain what is happening at the school level in this data. What is happening at the platoon that can help us explain this relationship between well-being and leadership consideration. So this is the beauty of multi-level models. This is the advantage that up till now, whatever we were doing was only at one level and we were saying this is the overall trend. But no, I want to be more accurate in my analysis. I want to show that there is group level variation and there are group level predictors that I can bring in to my model that can help me clearly point out that this variation is because of this particular variable. Conventional methods assume independent observations. I talked about it. Okay, knowing the information of one individual tells nothing about other individual information. Often not realistic in management research. Individuals in the same group, they have the same context and therefore they are more similar, right? Individuals within a same school share a lot of common characteristics, so they will show lesser variation, so the standard errors would be smaller. And this is a beautiful diagram. What is the general assumption of regression? That you have group 1, you have 3 individuals, they have nothing in common, right? Individual 4, 5, 6, 7, 8, 9, they are all different colors. Okay, and this meets the independence assumption of regression. But I will show you another picture. This is independence. That means all individuals within group, they have nothing in common. Okay, so I can use the normal regression model that I was using. But I show you this picture, beautiful diagram. You see, this is a blue group. Now you see individual 1 has some impact here. This has some common. This person has some commonality which is coming from the group. There is, yes, there is uniqueness because of the individual, but they are sharing. Look at this. There is something in common. There is something in common between these. There is something in common between these. And that is something that violates the independence assumption, and therefore we get wrong results. We may get inflated T statistics. We may get inflated alphas if we don't model this hierarchical nature of data, right? That is what this multi-level models are doing. I talked about this. This is independence, but then there is clustering. So there is overlap. Ignore clustering and your standard errors are too small. But then there is clustering and you get inflated information and you get inflated type 1 errors, inflated alphas. I talked about it. The t-stat is going to be inflated. So you are not just testing at alpha equal to 0.05, you are testing at alpha which is greater. Okay. Yeah, I will come to this, but let me just take you to this table and then we will take a break. This is the inflation. So if there is commonality, if there is no commonality, then your alphas, so ICC is, that means there is nothing common. I will explain what ICC is. Don't worry about ICC. Just assume if ICC is 0, that means there is no impact of L2. So your alpha is actually 0.05. This is simulation, and this paper is, it comes from this paper. If there is commonality of 1%, this is 1% commonality, then you are not just testing at alpha of 0.05, you are testing at alpha of 0.06 if the group size is 10 average. If the average group size is 25, you are not testing at 0.05, you are testing it at actually 0.08. So look at the inflation of alpha. If the group size is 50, you are not testing at 0.05, actually you are testing at alpha of 11. And look at this. If there is 20% overlap, then what you thought is alpha of 0.05 for an average group size of 10 is not 0.05, it is actually 0.28. This is the alpha at which you are testing. And if the average group size is 100, then you are not testing at 5%, you are actually testing at 70%. That means your type 1 error is not 5%. The type 1 error is actually 70%. That's the impact of clustering. That's the impact of hierarchical nature. That's the inflation that we are talking about. If there is 20% impact of L2 variables, then your alpha is actually 70% for an average group size of 100. And right? Yes, Kanika.
So I'm again trying to apply it to what I've been doing. I mentioned this to you last time that I'm looking at clusters by using the latent profile analysis. So in that I get groups of people which are homogeneous in terms of a particular variable. For example, if I'm examining perfectionism and mindfulness, which are the people who have a certain common average score on perfectionism and mindfulness, and that is a group. And then I have an individual level variable. Say for example, my dependent variable, I'll take say work engagement. In that, if I'm running this group level regression on an individual level, again I'm actually risking my results to inflation, right? Because I'm actually running it on group to an individual level variable.
No, then you can model those. So you can create based on your latent analysis, you can create those as separate groups. Okay. And
Yes, sir.
you have some group level information. Okay. So you
Yes.
can model those as
Yes.
L2 variables. And then
Yes, correct.
test the impact of those L2 on L1 variable, which is your work engagement.
Okay, right. So this is applicable in that situation, right?
Yes,
Because I've
yes,
got those clusters, right?
yes. But how many clusters?
So 4 or 5.
No, then don't do it. Then it doesn't make.
Okay.
Yeah.
Okay.
And the
Okay.
power would be too less.
Sure, sir.
Then
Sure.
you can
Okay.
just do the
Corresponding
concatenation or
analysis and know
correspondence.
how.
Yeah.
Okay. So, but in that case, if we are
For
running a
multi-levels,
regression,
as I said, the general recommendation is you should have
is
30 separate groups in general.
okay, sir. So, but if I run a regression analysis on such a combination with clusters, with groups, and then individual level variable, then in all likelihood, the coefficients are going to be more inflated, right? In that case also.
Yes, a little bit, but you don't have too many groups also, right?
Yes, sir. Yes,
So
sir.
then it will not be that much of inflation. You see, this table is telling us if the group size is 10, but how many groups you have, that also. So I think the inflation is not going to be too much. And for 4, you
Okay.
can also create 3 dummies.
Okay. Okay.
So do dummy level regression, dummy variable regression. So you can call those as 4 groups, create 3 dummies,
Okay, sir.
and then you can
Run the
check,
analysis.
then do the regression analysis.
Okay, sir. Right. Thank you.
For a large set of groups, we cannot create so many dummies. That is why we do
Sure.
multi-level models.
Got it, sir. Thank you.
Yes, Deepak?
Sir, I have one question related with the inflation of the t value.
Yes,
So basically, as you said, t is inversely proportional to standard error,
standard error.
and standard error is directly proportional to the deviation.
Yes,
So basically, when we are talking about regression, then we are considering the assumption of independence,
yes,
that the classes are not correlated.
correct.
So in that case, what actually it means, independence means we are saying that there is no variation.
There is no, not variation. The correlation between
Classes.
the correlation between the observed values is 0.
Yeah,
That
that is our
means,
assumption.
yes.
But in
Yes,
reality,
but
it's
in reality,
we have,
because they are nested,
yes,
there is going to be a correlation. So they are actually not independent.
yes, that means they are dependents.
They are dependent, and this dependence means, so if I am correlated, obviously our variation is not going to be that much, which it should have been in a case when we were independent, right?
So in that case, what happens to the standard deviation?
Standard deviation goes down. See,
Yeah,
standard error
yes, yes,
is a
that's
function
why.
of standard
Yeah,
deviation.
Yeah,
So the
that's why.
standard deviation goes down. Standard deviation goes down, standard errors go down,
And T inflated.
and T becomes inflated.
Yeah. Got it. Thank you.
Standard error is derived from standard deviation.
Deviation, yes, yes. It's
So your variance goes down, ST goes down, standard deviation goes down. Standard deviation goes down, your standard error goes down. And your standard error goes down, that means your T becomes
T value inflated.
inflated.
So basically it boiled down to the R wrong assumption.
Our wrong assumption, and we did not model it.
Yeah.
Okay? So you must simply understand that if the diagram that I showed you, right? This diagram, that if they are not, that means there is something now which is common, right?
Yes, yes.
If something now is common, that means the variation is not as much as it would have been. If the
Yes.
variation is not that much, then the standard deviation, which is just the square root of variation, is not that much.
Yes.
And if the standard deviation is not that much, that means standard error, which is directly proportional to standard deviation, is not that much.
Yeah.
And if the standard error is not that much, then that means your T is higher, because
Yes.
standard error comes in the denominator. Correct?
Yes, yes.
Yes.
Got it, sir.
Yes.
And one more, sir. Even if it's a level 1, or level 2, both are not multi-level. That is a simple analysis.
Yes. We simply say it is not. See, it is L1 only. So
Yeah,
it is only
L1
one
only.
level.
Correct.
L2 only. So it is only one level.
One level.
It is only at L2.
Because in
What is
one of my
multi-level? When you have combined variables at multiple levels.
in one of my objective, I aggregated to the level of the company.
Yes.
So that becomes only one level.
One level. So you can do simply normal
Simple.
regression.
Yes, yes. Thank you,
Because
sir.
you are not talking about any cross-level effects.
Cross level. Yes.
Yes.
Got it. Got it. Thank you.
Yes. Yes. Pavan?
Yes, sir. So my question is related to the earlier discussion, like when to use multi-level regression. So in most of the times in economic studies, mostly including the data which is as this socioeconomic surveys, right, where the households are generally being nested in villages or states or countries for that matter.
Correct.
And the sample size is too large, let's say 45,000, 50,000. And even the village number, the community level number is also around 8,000, 9,000.
Yeah.
And so most of the studies what I've seen is that a basic regression, whether it is cross-sectional regression or longitudinal regression, has been accepted in most of the high-quality papers also which I've seen. So, and where I've seen that multi-level regression is considered, where they are asked the specific question, like whether there is a village level variation or a regional level variation or not. So, do you think to
And is
use
there a village level variable that impacts these
that
relations?
impact? Right. So, like, do you think when we have a research question which specifically looking into this aspect, at that time only we should use multi-level regression, or in general aspect, whenever we are using any socioeconomic survey, we should go for MLM, or again, like,
Well,
what do
yes,
you, what should be the
but
approach?
then see again, I would say modeling multi-level is a good thing, but then you should also ask the right kind of question. What is that level 2 predictor that I'm trying to assess? See, if I just say that there is a village level impact, okay,
Right.
is that a useful thing to write? Village level impact, but what is that variable that is impacting that relationship? That becomes an important question to answer, right? So you should have actually theorized that there is a level 2 variable that is important to be tested. I have captured it, measured it this manner, and then I am trying to assess. Otherwise, it is just so that you can also do, Pavan, simply by doing ICC1 analysis and saying how much variation is there at the because of the village level.
Okay. Right.
Okay. And then I simply just do, but you are not asking anything specific about what is that level 2 variable that is impacting this change. So you will understand when we start writing mathematical equations that a better question to answer is what is the what is that level 2 variable that I should check?
Understood.
Yeah.
Thanks.
Okay, good. So I see a lot of interest and good, nice questions. So it's about 4:50. It's time for a break. We'll take a 15 minutes break and we'll come back at 5:55 and continue the discussion. Okay, so we'll stop for 15 minutes and come back.